Great, thanks, Ken. So the conversations that we've had today and what's been presented today is Sarah and I were sort of talking about this earlier, that the themes that we put in here, really, there's a lot of similarities. And one of the issues that we really want to talk about, there's a lot of bright minds in the room, there's a lot of bright people in the world, but really, that really has to scale significantly in order to affect the change and the amount of time that we have. And so I'm really glad how Ken set it up earlier this morning. So basically, I'm going to talk about where we really need to focus and how that relates to manufacturing and scaling this up and the real issues that we have to address in that. And so we're going to have two parts of our presentation. I'll start the first part, mainly focused on some of these issues and AEC sector focus, and then Sarah and I will switch and she'll cover the manufacturing side. So let's dive into it. Okay, go ahead. Okay, the elephant in the room, something that Ken touched on, a few others touched on, but is generally in most people's lives isn't really discussed and isn't really in their normal daily life of the reality of what we're doing. And so let's click the next one. And so this is a short NASA film measuring CO2 over the planet. And this graph is showing the concentration in Hawaii, in the observatory up there. And in the past 7 years, this has grown 12 parts per million, which puts us on track by 2015 to be at 400 parts per million. Now, earlier Ken said, what is that 400 parts per million? Well, that's the 2-degree threshold of what we're hitting. And so that's going to happen in the next 5 years. And so this is a serious issue. Next slide. And so some of you may be aware of the Arctic perennial sea ice, the significant melting that's been happening on the North Pole. Go ahead and click it. Get the movie going. In 2007, this was the lowest amount in recorded human history that we saw up there. Now, a big issue, and you see the consecutive years starting from, I believe, 1979 in that view on the left. The big issue here is when we get so much open sea exposed that this absorbs a lot more solar energy than the ice. And so you get an acceleration effect going on. This sort of melting does not raise sea levels. It's only land-based ice. So for now, not much to worry about what people would think. Next slide. So Greenland, go ahead and click on it, starting in 2003, 2008, is losing ice mass. And this is shocking everyone that we weren't expecting this to happen so soon. But Greenland, which is land-based ice, is losing ice mass at accelerated rates that no one was predicting. So this purple, blue, light blue, and green are areas where mass loss is occurring. Next slide. And then, this isn't a movie, sorry. But this is the mass variation in Antarctic, which is also land-based ice. So this is a serious concern. Next slide. And so this group, the International Scientific Congress on Climate Change, this is a group of scientists. Scientists are by nature very conservative. They have to publish their work. They have to defend their work. And so to go out on a limb that says we are at the worst case scenario by all measures than the Intergovernmental Panel on Climate Change report in 2007 stated is raising a red flag to every government on the planet. You know, some people talk about Copenhagen saying it was a failure. It was a tremendous success because the number of people who went there and the little agreements that they moved forward on was a tremendous success. So next slide. So, you know, what's the problem? What's driving all this? Well, it's the plants. Next slide. And not a Reagan issue, but actually power plants. So this is a fossil fuel mix on the planet. So roughly 3,000 gigawatts of the capacity of our electricity generation is coming from fossil fuels. Now, what Michael spoke about earlier was that buildings use approximately 70% of the electricity generated. And that's pretty much this portion here. And so he also indicated that buildings had a significant potential to really reverse this. A lot of money is being spent in clean energy on the supply side, you know, solar and wind. And we can see the very little amounts in those sectors there. And if we look at what's happened, go ahead and click it, in terms of power plant installations, including wind, PV, nuclear, and fossil, over the past 4 years, fossil fuels are still dominating what power plants were putting in place. And this is primarily in China, this power plant mix. So the PV current rates of growth in PV and wind, it will take us 50 to 100 years to meet this capacity. So that's not going to get us out of the problem. Nuclear, in this period of time, about 1 gigawatt of installation. Now, there's a lot of plans being built. I think about 55 gigawatts, but it's still a significant amount of time to get that in place. Next slide. How many are you familiar with the McKinsey abatement curve? Okay, so for those of you who are not, I'm going to give a little bit of detail here that I normally would. So this is a study that McKinsey did to figure out how much would be required to save 3 gigatons per year of carbon emissions and what that cost would be. And these items that have a negative cost are things that pay for themselves, like efficient lighting. You know, you pay for that, you install it, the utility savings pay for that thing. These things above zero don't pay for themselves. And you'll notice that there's things that are on the supply side, you know, all in the power plant. Those aren't going to pay for themselves. You'll see, go ahead and click it, these things that are highlighted in the left, those are all building changes. Lighting systems, envelope systems, the equipment, you know, residential electronics. These are things that pay for themselves. So we're finding that, click it again. And the other unique thing about this study is generally when an expert in building science, he would never only look at one thing and install one thing, like a lighting retrofit. The biggest bang for your buck is when you combine several of these things, because then you can pay for these things in that same study. He has a whole package. And that's the great thing about sophisticated analysis tools, is that you can do this really complex study, as Ken was mentioning, by incorporating all these things rather than the more simple analyses that are typically done by energy service companies. Next slide. So buildings is the primary focus to address this issue. Next slide. And Ken explained this graph. Next slide. So existing buildings. I want everyone to realize how many existing buildings there are in the United States. The majority of them are residential, roughly 100 million. Next big category is small commercial. And large commercial represents about 1% of the buildings out there. Now, if we're going to change things, you have to generally send someone to a site. And that's where this big piece of the pie is not cost effective to do these things. You know, you won't be paying someone to do a sophisticated analysis to scale up to that big piece of the pie. When you do that sophisticated analysis and you identify these opportunities, it's probably only cost effective to do energy service companies on this large portion. That represents 1% of the market. Next slide. But that's still about 14% of the cost out there. So they are hitting a big piece of the pie in terms of energy use, but not really having an impact on 86% of that pie. Next slide. Now, if we look at the building floor area, Michael mentioned this, you know, there's old data, 70 billion square feet in the United States. New construction still alive, primarily in China. And so China's putting in place 20 billion square feet of building area per year. Think about that, yeah. And so that's in roughly a little less than 4 years. They're putting in place equivalent floor area as commercial buildings. So that's why all those power plants are being put in place, because they're having to power all this stuff. So this is daunting. Next slide. But it's a big opportunity. So if we look at the U.S. existing building stock, you know, we're up here in terms of efficiency. You're seeing in these blue diamonds are ASHRAE 90.1, and it's updates. And you see, whack, someone's getting real, in tune with the reality and the frequency of these updates, and finally focusing on 2030 to be net zero energy. You know, everyone's targeting this portion here. Next slide. This was sort of a manual that sort of started the whole LEED U.S. Green Building Council. It was published 14 years ago. It was written by David Gottfried and a bunch of other bright people. 14 years ago this was published. LEED is still niche. You know, its impact on this problem is really infinitesimal. And it delivers average energy use. Next slide. This is a study that New Buildings Institute did of all these LEED buildings, I believe 121 buildings. And there's been other studies that validate this research. You pay for a platinum building and it's using more energy than a code compliant building, you're going to be pretty pissed off if you're the owner. So the problem here is that this is a complex situation, and people getting it right is a hard thing to do in terms of predicting and finding the energy use. Next slide. So I mentioned earlier that governments were getting in tune with this thing. So the US federal law, starting this year, every new and renovated federal building has to be designed to use 55% fossil fuels. And that will continue going down to be carbon neutral by 2030. UK is moving forward to have buildings, residential sector, to be carbon neutral in 2016, and all new buildings by the end of the decade to be carbon neutral. California is moving for that, net zero energy in 2020, and commercial sector by 2030. European Union, the European Parliament overwhelmingly voted for this to be put in place, that every new building in the EU starting in 2020 has to be net zero energy. My personal feeling is this, it's even going to get more aggressive than this. And what's a sign of that? Next slide. So New York City, last Earth Day, New York mayor said, we're going to put in place this really aggressive energy efficiency program for existing buildings. And everyone said, this guy's loony. It was signed in December of 2009. New York State, this is a really interesting one. This was overwhelmingly voted in favor by the legislature. And what this is it's a jobs program. And the reason why it's a jobs program is they're making money available to 1 million buildings over the next 5 years to be renovated in the small commercial and residential sector. And what that does, because they recognize it's so cost effective to do this, you pay for those renovations in these buildings. That stimulates the products going into those buildings to make those buildings efficient. That stimulates the manufacturing sector. That stimulates the supply flow and all the commerce and the taxes that are generated from that. So they get all that money back. And that's being learned throughout the US as well as the world. President Obama said we want to be more aggressive with our emission reduction. So in the entirety of the federal government, setting a goal by 2020 of a 28% reduction. And the American Clean Energy Security Act, which passed in the House last year, upon signing, all new buildings will have to be 30% better than code. And then by 2015, 50% better. Now the Senate's going to be picking this up again. They had to do health care, some banking reform, and stuff. But now they're going to get to this. Next slide. Now at Autodesk, we have a lot of tools. Not many people realize how big of a company in terms of the amount of products that we have that span the design community and the media and entertainment community. And one of the things I did when I went out there, after I came into Autodesk, was I looked at what products we have that could sort of accelerate this issue, in solving this issue, excuse me. Image Modeler is a product that you can take pictures, digital pictures, and then you can reference them to drawn 3D. And so we got these products, Revit, which is a BIM tool, Green Building Studio, SaaS-based energy analysis. And we hired a guy, and we said, who didn't know this domain, didn't know these products, and we said, your task is to analyze 6 of our facilities on 3 continents. And we want you to use this process to validate if this really works or not, and compare it to the utility bills. Next slide. And so this is a Toronto facility. He's drawing over the pictures in 3D. Next slide. This is that same building in the Revit in terms of BIM. Next slide. Submitted all these buildings to Green Building Studio. See them all in one location. Next slide. This is Shanghai facility. And then next slide. These are the results he got when he compared it to the utility bills. And so he was pretty disappointed. He's new, green, neophyte, I mean. He was like, I'm wanting to get these to 0. And anyone in the energy analysis building science group says, these are phenomenal results for a guy who's just learning this skill using these simple tools to get. And the other astonishing thing is the first one took him about 3 weeks. There was a lot of pain learning this process. The last one took less than 3 hours. So when this type of work, number one, you wouldn't do whole building energy analysis on a renovation of a building because it's just not cost effective. This approach all of a sudden is a real scalable solution that you can do when you're down to 3 hours per building. And the thing when you're down to this level, when you have a model that's sophisticated like this, you have to look at all these permutations of the building, all different products, things of that nature. And that takes a lot of time and expertise. So that's where we get into the scaling issue. Next slide. Oh, before we get to scaling, let's talk some Luddites. Because evaluating typical practices, we have a learning issue. Again, was a theme that was spoken about earlier. Next slide. When we launched our Retrofits Renovation program, we put a game on our website to educate people about this. And next slide. One of the things that we recommend is replacing old single-pane windows. And the world is littered with them. These are, you take an infrared picture of a building, you just see the energy coming out. But the old way is, it's never cost-effective to replace these things from an energy cost standpoint. And next slide. And so someone posted, reviewing this game, saying, this is crazy. Why would Autodesk recommend replacing windows? And this is what we're facing as new technologies are rapidly coming into the market that can radically change the game. That you'll have people who are stuck in their ways and aren't researching and going to the facts and finding out what exactly are they talking about here. Next slide. So Sirius Windows has a window that essentially makes that window equivalent to an opaque, the wall in terms of thermal performance. That changes the whole game in terms of existing buildings and windows as a renovation. When you renovate this, all of a sudden the heating requirements of that building drop. So that boiler doesn't have to be as big. Saving money there all of a sudden pays for this. It just changes the whole equation. Next slide. So scaling. How do we inform people about all this? All these new products, the sophisticated analysis, and that's where Autodesk is really focusing on this problem. Next slide. So SaaS, software as a service, the cloud, whatever you want to call it. The amount of time you can do one simulation. With that cloud, you can do dozens and dozens of simulations. And those simulations can be different permutations about that building. Different lighting, different windows, different insulation, different occupancy behavior. You're going to be really brutal about it. Or qualifying products. And so Autodesk has a site which Sarah's going to talk more about called Seek, where all these building products are. But you need performance data, both in terms of operation and life cycle, to really inform the whole system so people can make those informed decisions very quickly. Now I'm going to turn it over to Sarah to talk about that on the manufacturing side. And I get to drive it back.
That's right. All right. Thanks, John.
Sure.
So I thought we'd start with this image. If the statistics that John gave you weren't daunting enough, let's focus on the P part of the equation that we saw earlier today. So this is a picture of an Indian family, and they're riding a scooter. It's quite likely that the gentleman in the helmet was probably riding a bicycle or walking prior to this generation inside this multi-generational group. And now we see all the children on the scooter, and it's quite likely that they'll be driving Tata Nanos, or they'll be doing other means of transportation. And this is a resources issue. It's also a land issue, because the road infrastructure inside these countries is going to need to change to incorporate all these different momental shifts that are happening inside our economy. Our senior vice president went to Davos this year. He participates in the Sustainable Consumption Group there, and brought back a really scary statistic that really woke me up. He said by 2030, there will be 2 billion new consumers in the world economy. So 20 years, 2 billion. And that's from the emerging countries alone. And if we look at that, if we set sustainability aside for a second, and look at that just in terms of materials and resources and energy, those commodities are going to get more and more expensive. So that really necessitates us moving this along and scaling up, just as John said. So I thought it would be interesting to look at how somebody's trying to scale up a clean technology that solves some of these problems in India. So this is a product that's really near and dear to my heart. It's called D-Light. I saw it, I think, first in 2005 at the Net Impact Conference at Stanford University. And basically what it is, it's a really simple portable light. It's meant to displace kerosene lighting in rural Indian communities. And it's facing a lot of trouble getting deployed. The first reason is around funding. I think, as anyone knows who's looked into startups and early stage companies, there's a low capitalization problem. So it's really challenging for them to get those resources online. And then you also have the problem, maybe it's not a problem, but it kind of is, around venture backing. So they've got this money coming in, but it's not really showing that they're selling the products and then they're scaling and growing, as we talked about appropriately. You also have the problem that the light is too expensive for the folks that they're trying to sell it to. So companies like the Red Cross, or organizations like the Red Cross, are coming in and granting 35,000 units to Haiti or to other communities that are in need. So that's happening, but it's not a really natural growth pattern. It's being sort of induced and helped along by these other companies. And we're also facing a skeptical market. These Uttar Pradesh households aren't really sure. They're saying, what if there's a dust cloud? Or what if the sun stops shining? Am I going to be in the dark in the evening? My kerosene lamp never gave me that problem. Is this going to happen with a new solar-powered technology? And the founder even speaks to the scaling issues. He says, I'm constantly wondering how to effectively scale up. Next slide. So what we wanted to do today is, I think we're all facing these problems in our positions in one way or another, and we wanted to identify the barriers to scaling up and then really start a meaningful discussion about what we can do to solve them. Because I think, as we've heard over and over again, we just have a really compelling seat. I happen to think that I have the coolest lever in the world to affect change, because I sit at the point between 100 plus products and 9 million designers who use our products. And we're all sitting in that seat, and we all have a responsibility to do something. So these are some of the barriers that we've identified. We'd like to hear what barriers you guys are coming up with, and then hopefully in our discussion this afternoon, we can figure out what we're going to do about it. Next slide. So I thought it would be important to just show a little bit of case study about the silicon ingot shortage in 2006. So people finally were interested in photovoltaics. They wanted them deployed. There were great financing models. There were state incentive programs to get these things put on rooftops. But there wasn't enough supply. I mean, if you look at the polysilicon price back in 2006, it was at $225 per kilogram. And now we're looking at 80. And between 2006 and now, we've had thin film solar come into play, which is less silicon intensive. But still, this was something that really hampered PV being scaled up. And I think we'd be a lot further along if this hadn't been the case. And to that end, Autodesk is doing work to really help clean tech companies in early stage get to market faster. So we've developed something called the Clean Tech Partner Program. I won't go into it in depth, but you can get some information on our website. And this is a way that we're really trying to help these companies get to market quickly and further these clean technologies that are going to help us with these carbon mitigation techniques. And I just wanted to show one of the companies that I really like. This is Synchromatics. This is a company in our Clean Tech Partner Program. And what I like about this technology is that, yes, there's an on-site generation source, but also this is inspiring a behavioral change, which I think is something that has been a pervasive theme, maybe a quieter theme, but something that's worth exploring. So what this technology does is it's a sign that goes on top of bus kiosks and train kiosks. It was developed in Inventor, and it was developed, there's a lot of analysis and simulation that took place to make sure that it would be something that worked in a lot of different climates. And what it does is it tells you when the next bus or train comes. And it also tells you how full that next bus or train comes, because for somebody like me in San Francisco, I use public transportation all the time. And sometimes the bus or the trolley is too full, and I can't get on it. So what this does is this helps people say, okay, I can use public transportation. There's something predictable here. I know when it's going to come, I know how full it's going to be, and I know when the next one's going to come. And that really helps with the consumer confidence piece that I think we're also hearing about when we talk about those carbon calculators. With the over 40 in the market, they're all returning different results. And that erodes customer confidence in these solutions that we're putting out there to try to solve these big problems. Next slide. And that hits the second barrier that we're seeing, combating skepticism. So there's skepticism about the problem, right? So global emissions went down between 2008 and 2009. And those of us in the room who are watching these trends know that that's because of a global economic downturn. It's not taking into account all the production that's going on in Asia and in other emerging economies. They're even saying, will this new technology actually work? The Sirius Windows example that John gave. So that's an amazing new technology, but if you're doing this huge upfront investment in getting rid of all these windows in your building, how likely are you to trust this newfangled thing? I mean, I think we all, I don't see a whole lot of iPads in the room here today, and we're probably all waiting for that next version to come out because we want it tested out in the market. But if we're going to scale this and we're going to solve these problems, we need to help dispel the skepticism that's out there. And then lastly, we're really, I think, lacking a robust sales channel to sell. Next slide. So as we said, BIM forever, I think I'd also like to say digital prototyping forever. For those of you unfamiliar, digital prototyping is sort of the brother or sister to BIM inside Autodesk. So it basically makes a robust environment to do a lot of simulation and analysis on manufactured products. And we see a manufacturer sitting in the convergence of these two spaces. So you can actually do quite a bit of analysis here and then push it over into the robust engines that John was talking about and get even more building performance knowledge. So we see this as a really great direction to move forward. And John mentioned Autodesk Seek. So this is a CAD-agnostic software platform that we've developed on our website. You can go at seek.autodesk.com. And basically what it is, it's a catalog of all sorts of building products. Next slide. And I took a record of one of them. This is an LED light fixture. And you can see that they're Revit files, but also more interestingly, there's IES files posted to this record. So you can get performance information about the building products that are posted on the website. And we think that this is really going to immensely help folks get some of the data that they're looking at. And those are the three barriers that we have outlined as the most serious to us actually scaling sustainable design. And we would love to open up to a discussion to hear what your challenges are.
Questions? Oh, come on.
Well, I'll start. I've got a question. John, on your slides, you
Yes.
showed a 30% number for 2010 for automatic improvement of upgrade as a requirement by law.
That was the legislation that was passed in the House, so it's not law yet.
Okay. But the question that I have is, how do you count that? By what metrics do you use to say this is 30% more than what?
Yeah, so that's based on energy code, so it would be relative to ASHRAE 90.1.
Okay, so the 90.1 is the measurement that they're comparing against.
Yeah, for that legislation, it was relative to 90.1.